So any idea how to start the solution? Now this is a question of fed DC distribution fed at both the ends at unequal voltages. Okay, so that condition is same. Then the load here is not constant, so you cannot show it at a particular point, as we have done till now. Completed the question. I will go for the solution. चल रहा है क्वेश्चन लेकर चल रहा है?
Yes, sir.
I have just take a photograph of my copy, so it may not be so much good in handwriting. Now here, look at the figure which is on the right hand side. So this track is between A and B, okay, and the load here is shown, which is the train which is taking 300 amperes of current, and the point M is not a constant point. It is the train is moving from A to B, so this load is moving from A to B. Okay. Now here the question is, what is the point of minimum potential, and when the train is at that point, what should be the current fed from the point A and point B? Okay, so let us assume that the point of which is at a distance of x from the A side or A point. Okay, M is the distance, or M is the point where the minimum potential occurs. Okay, so I am just going to concentrate on that one, that the train is static at that point where the where the potential is minimum. Now, if that is the condition, x is the distance here, the distance from the other side will be total length minus x. Okay, so total length is given in the question is two substances 6 kilometer apart. Okay, so if this is x, this will be 6 minus x is the distance when I am talking about in terms of kilometers. Okay, so what will be the potential at point A if I will move from point? Now, as already we have discussed, if this is the M is the point of minimum potential, the current will be fed from either side. So the current here 300 ampere will be summation of a current from A point and a summation of current from the point B. Okay, so whenever the point which is at minimum potential, current is fed from both the sides. So let us say the current fed from A side is IA, and current fed from the other side will be 300 minus IA, because total load is 300 ampere. So I am now calculating the potential at point M from moving from point A. So Vm can be written as Va minus IaRm. Ram means the resistance of the distance AM. Okay, so resistance is given, to and fro is 0.04 per kilometer. So you can find for x kilometer, x into 0.04. Okay, and the same potential if I calculate from the other side, which is the point B, will be 590, or that Vb minus the drop in this Bm. Okay, so current is 300 minus Ia, and the resistance you will be calculating for the distance Bm. And what is the distance Bm? Total is 6 kilometer. This is x kilometer, so this will be 6 minus x kilometer. Okay, so here you can see Vm. If I will measure the voltage from point A, Va minus IRM, and it will be equal to the same Vm will be equal to Vb minus 300 minus Ia, because this is the distance, into Rm. RMB actually, this is RMB. Okay, so if I will equate these two, here in this equation, Va is 600, Vb is 590, Ia is unknown, RAM is known, because the value of that is given 0.04 per kilometer, so x into 0.04 kilometer, and here RMB will be 6 minus x into 0.04 kilometer. Okay, so if you will substitute
सर सेठी लेफ्ट साइड रे 600 minus 0.04 x भी तो गोटे रहया दरकार
କୋଉ इक्वेशन में
सर जो VA माइनस IR RAM लिखिଛନ୍ତି ता जस्ट
हाँ
तळटा 600 माइनस 0.04 x गोटे रहइबा
ना
କଥା
ना एटा दिस साइड इज VA माइनस IA RAM केते
आज्ञा सर
into x एटे x रहे दरकार सॉरी x रहे दरकार ना एटी
आज्ञा सर
हाँ x
आज्ञा
रहे
सर
okay and the right hand side is 590 minus 300 minus IA into RMB so 0.04 into 6 minus x so there should be a term x here हैला ठीक एटा लिखि दियो 600 minus 0.04 into x okay into IA so if I solve these two you will get what will be IA in terms of x so that comes to be 640 sorry 341.7 minus 50x okay now the second equation is M is the point of minimum potential. Okay, so I am taking VM as VA minus IA RAM. So 600 minus putting the value of IA here. So minus 13.7x and 2x square. So just putting the value of IA and RAM here, you will get VM equation in terms of x. So as this is the point of minimum potential, I am going to differentiate it with respect to x and find out the value of x. So for VM to be minimum, dVm by dx is equal to 0. So you will calculate what will be x. So x comes to be 3.425. Okay. So that means the point, the distance AM is 3.425. This is 6 minus 3.428. Okay. Now once you have this distance, now you can put any of this equation to calculate the value of VM, either VA minus RAM or VB minus this one, and find out the value of minimum potential. Clear? Those who are not written, quickly write down, then I will go to the next problem. Completed? Okay. So now, last class I have told you about this ring problems. So let us solve few problems. Then you will understand the concept of ring structure or ring distributor. Okay. So let us start with the first problem. All of you get your paper and pen ready. So a 300 meter distributor has loads as shown in 13.45. So this figure I am talking about. Where distances are in meters, the resistance of each conductor is 0.2 watt. Resistance of each conductor is 0.2 ohm actually, 2 ohm per 1000 meter. The loads are tapped off at points B, C, D. Okay. And so if the distributor is fed at point A at 240 volt, find the voltages B, C, D. Okay. So this is a common problem in ring structure. So as you can see, this distance is given 60 meter, 80 meter, 90 meter and 70 meter. So missing 300 hochi. Total is 300. So 140, 230, okay, 300 meters. So this AB distance is 600 meters. So for each of the distance, first you find out the resistance. So find out the resistance RAB, RBC, RCD and RDA. It is given 0.2 ohm per 1000 meters. So calculate the resistance for 60 meter, 80 meter, 90 meter and 70 meter. Put the values in the chat box.
question टा टिके
just draw the figure first. ତମମାନେ କଲେଜ ଆସିଲେଣି? କେତେ ଜଣ କଲେଜ ଆସିଲେଣି? କେହି ଆସିନାହାନ୍ତି? ସବୁ ଘରେ ଅଛନ୍ତି ତ? ଭଲ। ଏ 65 ଭିତରୁ କେହି କଲେଜରେ ନାହାନ୍ତି ତ? ସବୁ ଘରେ ଅଛ ତ?
yes sir
ଓକେ। କାଲିଠୁ ତ ଯୋଉ ବର୍ଷା ହଉଛି ଘରେ ବି ନେଟ୍ ନାହିଁ, ମୋବାଇଲରେ ଚଲଉଛି, ଏ ସମୟ ଚଲେଇଲେ ଚାଲିଲା। ହେଲା? So first you find out all the resistance of each section, AB, BC, CD and AD. AB, BC, CD, ଆଉ ଗୋଟେ ରହିଗଲା। Okay, AD. Okay, once you have the resistance, then what is the method of solution? Let us say the current from this tapping, which is the power is fed from this feeder. Okay, so let us say the current in the section AB is IA or I, just I. Okay, and 100 ampere goes here, so the current will from current in BC will be I minus 100. Okay, just in your figure you write down current in the section AB. Let the current is unknown current, or assume a current I. Okay, in the section AB, 100 ampere is taken away from point B, so the next current in the section BC will be I minus 100. Okay, next there is another tapping of 70 ampere, so current in the section CD will be I minus 100 minus 70. Okay, then again there is a tapping of 50 ampere, so current in the section AD will be I minus 60 minus 80, sorry, I minus 100 minus 70 minus 50, so 170 220. Okay, so current in the section AD will be I minus 220, AB I, BC I minus 100 and CD I minus 170. Okay, so these are the current in each section and the resistances already you have calculated. So now you write down a KVL equation in this closed loop using that resistance and currents. Write down a KVL equation in this closed loop, okay, taking the currents and the resistance value, and one current will be only unknown, will be I. You will be finding the value of I. Clear? Anyone not able to get the understand the problem? The current I am assuming in the section AB is I. So when I move to the next section, 100 ampere is taken from here, so the current in the section BC will be I minus 100. Again 7 ampere goes here, so that becomes I minus 100 minus 70, so that is I minus 170 in the section CD. And similarly current in the section DA will be I minus 100 minus 70 minus 50, so I minus 220. So now all the currents are known, all the resistances are known. Write down the KVL equation in the loop ABCDA to find out the current I. Write down the KVL equation. At a single conductor there is a double. The resistance of each conductor is given 0.2. देखो कि Rahul, you have, I think you have not multiplied 2 in each of them. Write down the KVL equation of A, B, C, D, E, A, B, C, D and A using those current and resistance, and find out the value of I. सरला केसन लाउची गोटे केभिल इक्वेशन सॉल्व करिया पई 1871 ना 1.871 केते लेक्चर एते करंट आसीबन तो देखो ठीक से देखो
सर 1871 आछी
अरे ये तो करंट नउची 170 220 टोटल नउची एते करंट केम नबो 129 के जन तीन जन गस्ची most probably that may be the right answer. Once you have that current, then how to find out the voltages? One more thing. Now, assuming that 129 is the correct answer, because I am not solving here. So 129, with that current, you find out the current in each section. Okay. So if this current is 129 in the section AB, this will be 29. 100 goes here, so 29 here. Okay. 29 minus 70 will be this current. That means the current direction will be opposite. Okay. So 29 minus 70, so around 49, sorry, 20 50. So 129, 29, 70. 41. So 41 ampere will be flowing from D to C. Okay. And plus 50. So 41 plus 50, 91 will flow from A to D. So here the direction of current will change. So accordingly, whichever current is negative, because all of you know what is the current in AD, I minus 220. Okay, so if I put 129, you will get a negative current. That means the current in the NT will be opposite to that one. Okay, similarly, the current in CD will be opposite. It will be flowing from D to C, whereas the current in AB and BC will flow in clockwise direction. Okay, once you have the directions of current there, then you will be finding the voltages. So what is the voltage at point B? Either you move clockwise manner or you move in anti-clockwise manner to find out the voltage. So potential at point A is 240 minus this drop in the section AB will give you the potential at point B, minus the drop in the section BC will give you the potential at point C. Okay. Similarly, 240 minus the drop here will give you the potential D. So find out these three voltages. Be quick. EB कोटा E तो पॉइंट ही नहीं D ये अच्छी EB कोटा (41 ampere will be the current in the section CD, and the current here will be 91 ampere. AD will be current 91 ampere. Okay. So with those current, find out the potential of B, C, and D points. Correct. VP 236.9. Okay. Now let us go to the next problem where there is a interconnector. So just draw this figure first, 13.47. Draw this figure first, then I will read the question. So here there is a feeder point of point A and there are tappings at B, C and D. Answers are given here. VB 236.9, VC 235.97, VD 237.45. Okay. Now go to the next problem. Draw this figure first. Complete. So the question is, the network shown in 13.47 feeding point is maintained at 250. So the potential at point A is 250. The resistances of various branches of go and return are indicated in the figure. Determine the current in each branch. So resistance should have. Okay. So first, you do one thing, remove this interconnector and try to solve this problem. Okay. Remove this interconnector of 0.8 ohm and try to solve it. Let us say this current is I, this current will be I minus 12, this current will be I minus 12 minus 16, this current will be I minus 12 minus 16 minus 8. So remove this one. We are going to Thebanize the circuit across the point A and C. Clear? We are going to Thebanize the circuit across the point A and C. So I am removing this resistance 0.8 ohm. Okay. So first you remove this 0.8 ohm and solve the question as the previous case, moving in the outer loop. So this current, if I will say this is I, this will be I minus 12, I minus this one, like that you solve it. So always this method is remove the interconnector and solve the problem and Thebanize the circuit. Okay. So first you find out the current I into 0. Write down the closed loop equation. When you remove this 0.8 ohm, so this current is I into 0.4 plus I into 0 I minus 12 into 0.8, I minus 28 into 0.4 and I minus 36 into 0.4. So sum of all these voltage drops will be equal to 0. This is the value of I, 17.6. Is it clear? Same for all of you? Okay. So once you have that current, find out the potential drop between the point A and C. How will you find out that? Now once you have the value of current or value of I, you can find out the branch current in each section. Okay. So between the point A and C, the potential difference will be VAC will be equal to this drop plus this drop. So I 17.6. So 17.6 mane this AB current is 17.6. BC current is 17.6 minus 12. So 5.6. Okay. So VAC can be written as I into 0.04 plus I minus 12 into 0.8. That will be VAC. Be quick. Find out VAC. That VAC is the Thevenin voltage or the open circuit voltage.
सर आईएससी टा कहला टिके आउथर कहबे
You have calculated the value of current.
यस
Okay. So the current in the section AB will be 17.6. Current in the section BC will be 17.6 minus 12.
यस
Okay.
सर यस
So we need to find out Thevenin ame kon korchu load ta ko remove kariki we are finding the open circuit voltage. Okay. So here the open circuit voltage is the voltage between the point A and C. Okay. So that voltage is equal to this drop in the section AB and drop in the section BC. So A theta drop kete voltage current into resistance, this current into resistance, calculate the drop in the both the sections, that will be equal to VAC or V Thevenin.
यस सर
That VAC is nothing but V Thevenin. यार कोन 11.52 तार कोन 15.2 एते केंदी असला What will be VAC? VAC will be 17.6 into 0.04 for the section AB and 12 bolle 5.6 into 0.8, that much. 17.6 into 0.4 and 5.6 into 0.8. So that should, I think it should be coming 11.52. Asti samastam 11.52. Now, once that voltage is done, then we will be going for finding R Thevenin. So R Thevenin kono? This R Thevenin is the equivalent resistance between the point A and C. Always remember, this is not there. This 0.8 ohm we have removed. Okay. So there are two paths. One path is through this one between A and C. Another path is through the point B. So I can say what will be the equivalent resistance between A and C? This path in parallel with this path. Clear? So find out the equivalent resistance between RAC. That is your R Thevenin. So there, these two in series, 0.4 and 0.8 in series. Similarly, 0.4 and 0.4 in series. And the total each of them will be in parallel with each other. So
सर एटी थेवेनिन कहीं करा गला
how will you solve it? You don't have the current in this branch. सिना गोटे लूप थिले आमे गोटे अननोन सॉल्व करदु एठी केतेटा अननोन नबो दी तीनटा अननोन नेकी दी सॉल्व कर परियो. ओके ଆମେ previous case ରେ କଣ ଏଠି ଗୋଟେ current I ଅଛି, I କୁ ଆମେ divide କରି ଯାଉଛେ, so when we are writing this KVL equation you are able to solve it. Here we don't have that situation. Either you have to take this equation or this method, or you will be using the method that let this current is this I1, this current is I2, and you can go on solving that. Okay, so if you will take this current I1, this will be I minus 12, I1 minus 12. Then this current is I2, so this current will it is 16 ampere there. Okay, so this current will be this current plus this current minus 16. Like that, you have two equations and you can solve it. Okay, that method is there, or you can use the Thevenin's method to find out the current. Your choice. Okay. What is RThevenin? Like the learning. Okay. Correct, 0.48. Now, once you have Thevenin resistance and Thevenin voltage, draw the Thevenin equivalent circuit and connect the 0.8 ohm there. So Thevenin voltage was 11.52, resistance is 0.48, and reconnect that 0.8 ohm again. Okay, now it is a simple circuit. Find out the current I. Nine ampere. Okay. Now let us go to these are all about DC problems. Okay. So as I have told, there are few types of problems on the DC distributor. One is the concentrated loading type, where you find out the concentrated loading. Also, there are two types: same feeding at one end, feeding at both ends, and then feeding at both ends with unequal voltage. Okay. Then uniform loading is there. And the third one is the combination of uniform loading and concentrated loading, and then this type of ring-like structure problems. These are different problems you will get from the DC section. Okay, so just we will start with the AC section, then next class we will. In AC, the difficulty will come because we have to take into account the phase angle. Okay. Now here there are two methods, and before going to that, there is generally this is a common question, and I think it was given in the assignment also. I think I have given you how many days? 8 to 10 days for submission of assignment. Still few are late by hours and days. What is the issue with you? I can understand. You are not able to write few questions or answers in 5 or 10 days. Huh? Now this is the first thing when you are changing from AC to DC distribution, these are the few things you have to keep in mind. Which is economical and what is the advantage of each of them. Okay. Now obviously in DC system we have only the resistance we are going to deal with. In DC we don't have the reactance, either inductive reactance or capacitive reactance is not there. Okay. So obviously when you are not having those two reactances, the effect of that is not there. The voltage drop due to both of them are not there. Okay. Second, in DC system, additions and subtractions of currents or voltages are done arithmetically because we are not going to deal with the angle. Okay, so here also you can see we have just when you are calculating, you are just adding one is 17.6 ampere, 5 ampere, 12 ampere goes there, so 5.6 ampere is the other section. But if you have AC, each of these figure will be complex numbers. So when you are dealing with AC, you have to deal with either polar form or in the rectangular form. Okay. In AC system, power factor has to be taken into account. Loads tapped off from the different distributor at generally of different power factors. Now there in DC, when you are saying that it is a constant loading of 100 ampere, we don't bother about the angle because it will be same for all of them. But in a AC system, you have to think that the load is R type or RL type or RC type. What is the power factor angle of that? Okay, so accordingly the current will be drawn and the summation of that current will be in vector. It may be referred to supply voltage receiving at the end, which is regarded as the reference voltage. Now, when you are finding when you have to give the angle of each of the current, you must be writing with reference to something. Okay, so there are two methods which are given for giving the currents. One is generally the end current, end voltage is taken as the reference. Okay, so if you have a distribution line, here you can see this is the feeder point, this is the end point B. So the power factors are referred from this voltage at the point B. Now here this situation is difficult because if you have a long line, how this load or what will be the current here, how it will depend on this voltage. It is not depending on that. It is only depending on the voltage BC. So if you are writing what will be the angle with respect to B, the calculation will be huge. Okay. So this method here you have only 1 or 2 tappings, so it may look easier. But let us say you have 5 tappings or 10 tappings, then you will not be able to, what will be the angle between the VB and this current I1, it will be very difficult to calculate. Okay. So this is one method. Another method is each load is represented with respect to each terminal voltage. That means the current here. No, that. Anyway. In another case, this current I1 will be referred or represented with respect to VC. Similarly, current I2 will be referred with respect to VB. That means what is the voltage available across it or what is the voltage across the load. According to that, the angle between the current and voltage will be given. And that is more practical one with respect to when you are going for calculation. Okay. So let us start with the first method. Power factors are referred to receiving end voltage. Okay, receiving end voltage means the right hand side, VB. So here you can see, consider an AC distributor AB with, so loadings are given I1 and I2. As I have told, the loading here will be depending on the type or RC load or RLC load. Depending on this, power factor angle will change. So here in AC, you have to give the angle or power factor along with the current. In DC, we are only representing it that at tapping, we have a current I1. At tapping B, we have a current I2. But here, we need to take into account the angle also. So if that is the case, calculation method is same. Only thing is the calculations will be done in a complex mode. Okay, a complex calculation will be done using the either rectangular or polar form depending on the use. Now here also in case of DC, the impedance of AC section was only the resistance. Okay, and the impedance of the BC section was also only given in terms of resistance. Here it is given in terms of impedance R1 plus JX1, and similarly here it is R2 plus JX2. Okay, so if I want to find out the voltage drop at each of them, now here you can see current I1 is written as I1 at an angle of minus phi 1, or in the rectangular form I1 whole into cos phi 1 minus j sin phi 1. Okay, similarly I2 cos phi 2 I2 at an angle of minus phi 2 or I2 into cos phi 2 minus j sin phi 2. So like as I have told, calculation will be more. That is the only thing. Concept will remain same. Now what will be the current in this section? BC will be current I2 only. Okay, current in the section BC will be the current I2 only. The current in the section AC will be I1 plus I2. But I1 plus I2 when you draw, when you do that, it will be done in the vectorial mode. Okay. So current in the section BC, you can see it is equal to I2. In the BC also we are doing the same thing. As you are moving away from the feeding end, the current was decreasing. Here also the current here will be only I2. So ICB is equal to I2, whereas the current in the AC section will be I1 plus I2. And when you do that, as I told you, you will be adding them vectorially. Okay. Now, once you have the current in each of the section, now what we are doing next? We are calculating the voltage drop. Okay, so VA voltage is known. So what will the voltage at point C? I1 plus I2 whole into R1 plus JX1. Okay. Similarly, what is the voltage at point B? If you know this voltage minus I2 into this impedance. Okay. So there you see voltage drop is given, calculated, and then voltage VA is equal to VB plus VC. This one. Like that. And sometimes also along with this you need to draw the phasor diagram. Now here in this method what we have done, all the voltages are referred with respect to VB. As I have told, this method is power factors referred to the receiving end voltage. So if that is done, then all the currents are, so here you can see I1 is lagging VB by that angle. This is phi 1. Okay. Similarly I2 is lagging it by an angle phi 2. Now when you are calculating that current in this section AC, it will be I1 plus I2. So this current is IAC, I1 plus I2. Okay. Now VB plus I2 R2 plus J I2 X2, because it is having R plus JX form. So VB plus this drop is equal to VC, and VC plus this drop is equal to VA. Okay, so the phasor diagram will represent in the same manner. VB plus I2 R2 plus J I2 X2 will give you VC. Okay, but with when you are what is the drop in the section AC, we have to take I1 plus I2. Okay, or IAC. What is IAC? This resultant vector. I1 plus I2 resultant vector is IAC. So here, when you add the voltage drop to VC to calculate VA, it will be IAC R1 plus J IAC into X1. So that will generate the voltage VA. So if you want a voltage VB available at the terminal or end, the voltage that will be fed to the input terminal should be VA. So like that, you have to do the calculation. Okay. So next class I will go to this second part. Today I will stop here.
सर से डीसी डिस्ट्रीब्यूशन नोट स्टडी पठे देबे
सबुडा अपलोड कर दिस बदे कोडा रही जाई छी कि देखिलो तम क्लासरूम में तो प्राय सब कर देइथिली अदर न करथि ताले आज कर देबी ठीक है ओके सो नाउ
रिएक्टिव पावर कंपेंसेशन जे पठे देले
अच्छा ना ना रिएक्टिव पावर कंपेंसेशन ता परे अच्छा हो मु देखियो हां ठीक है